Okay, so we're going to look at one of those applications of converting from standard form to vertex form. We're going to use completing the square. That's one of the applications of it. So we have a quadratic here, and this is in standard form. So we got to talk about that first of all. So that's a new form we're introducing. Standard form is in the form ax squared plus bx plus c. So a is the coefficient of the x squared term. We call it the quadratic term. B is the coefficient of the x to the first term, or the linear term, and c is the constant term. So this is in that format. So it's nice to know what a is, what b is, and what c is. We're going to have to identify those quite often in this form. So a is 1, b is 6, and c is -5. An important note is that the b and the c and the a, you got to pay attention to the sign in front. It's not just the number. The sign matters. So that's a little intro to standard form. We want to turn this now into vertex form. It's given in standard form. I want to make it into vertex form. So I can complete the square. Now what you want to do is we want to take the first two terms, the quadratic term and the linear term, and look at that as make that a perfect square. So that -5 is not going to be included in our perfect square, because we're gonna add some number in here to make it a perfect square. So from the last video, we know that that number comes from cutting the b in half. So I take the 6, I cut it in half, I get 3, and then I square it. 3 times 3 is 9. That makes it a perfect square. Now for vertex form, we're actually going to write this. Oh, first we have to do this. I'm sorry. So I just added 9 to the equation. So I changed it. So it's no longer an accurate equation. I just added 9. So to keep it as an equation, since I'm on the same side of the equal sign, I can just subtract 9 a little bit later on down the road over here. So that if I add 9 and subtract 9, it keeps the equation balanced, because the add 9 and the -9 are inverses of each other. They're inverse operations. I'm adding 9, subtracting 9. I'm back at back to the equation I had. So I have to do that. Whatever number I add in to complete the square, I've got to subtract it out at the end. And this is already starting to look like vertex form a little bit. The next thing we want to do is take that perfect square and actually write it as the binomial squared. So x squared plus 6x plus 9, that's going to be x plus 3 squared. Again, we did some practice on this in the last video, and we'll do some more practice in class. Outside the parentheses, I've got -5 minus 9, so that's going to be a -14. And that is now in vertex form. So we can complete the square to get vertex form going. That's one way to convert. There's a way that I think most students like better, and that's what we're leading to today. I'm going to kind of set it up so that you don't have to do this way, but you do have to see it and know how we do it. So I use completing the square to write the perfect square trinomial and then write it as a square, because we know in vertex form, this x minus h squared part, that's a perfect square. That comes from the perfect square trinomial. So that's all we're doing there. So this is our vertex form. Let's look at the next one. What happens if you have a number in front here? We can only complete the square when the a is 1. So when a is 3, we have to do a step first where we factor the 3 out. And we're only doing it for our perfect square part. We still have we're just looking at this part. We still have the -5 afterwards. So I factored out the 3. If I complete the square, I'm going to take my b, which is 6, again. Oh, sorry, no, it's not 6. It's 2 now. Because when I divide out the 3, when I pull this 3 out here, this is 3 divided by 3 is 1, and 6 divided by 3 is 2. So now I have a 2 inside there for the perfect square trinomial. So now, actually I'll leave it. I'll save this for the next line. What number do I add in here? I'm going to add a 1. Why is that? Because if I take my b, which was 2, divide it by 2, I get 1, and then we're supposed to do 1 squared. That was our way of making it a perfect square. That was how we completed the square. So if I add 1, I've now completed the square. Now, what I want to do is keep my equation balanced. So since I added 1 here, I'm not really adding 1 because it's in parentheses, and outside the parentheses is a times 3. So really what I've added was 3 because it's 3 times the one I added inside. I really added an overall of 3 to this equation, so I have to subtract 3 to keep it balanced. So that's the tricky part when a is something other than 1. X squared plus 2x plus 1 can be written as the binomial squared. It's x plus 1 squared. Then I can do my minus 5 minus 3, and now I have vertex form. All right, so let's do another one. This should be example 3. Convert to vertex form. Well, the nice thing on this one is there's no a, or the a is 1, so I don't have to do that factored thing. I'm going to start like this, and I'm going to say, what do I add in here to make it a perfect square? Well, you take the b, you divide by 2, and you square it. That's how you complete the square. So it's going to be negative 7 squared is 49. So I added 49 because there's a 1 out here, so that's all I'm adding is 49. I could subtract 49. So the perfect square factors into this binomial, x minus 7 squared, and then I do minus 1, negative 1 minus 49 is negative 50. There's my vertex form. This is why we're going through this. We're going to use completing the square, and I'm going to do it for any general standard form equation. And you'll never have to do it again if you don't want to. You can do it. When I ask you to convert from standard to vertex form, you could complete the square like I have here, or you can remember kind of a little formula that I'm about to derive for you. If I complete the square on this for any, this is for any quadratic, then you can watch me do this, and then we'll have a little formula that we could remember and use. This is a pretty complex derivation here. It's some serious algebra with all letters. There's no numbers, so it can get a little tricky. You'll never be asked to reproduce this, but you should try to follow along with me. You may not even, you don't even really need to write this one down in your notes. Just follow along with what I'm doing, and hopefully you can catch what I'm doing in each step. And if you miss something, not a big deal. So the first thing we're going to do is factor an a out, right? Here's I want to make that part into a perfect square trinomial. I've got to divide out an a. So it's easy to divide an a out from x squared. From ax squared, it's just x squared. How do you divide an a away from b? We can't really, so we just write it, b divided by a. Okay, if I were to multiply this back out, I would get back to my original. A times x squared is ax squared. A times b plus a is really just b because the a's will cancel. So this is the first part. Now I want to make it a perfect square trinomial. So what am I going to add inside of here? Well, I take my b over a. I divide it by 2. So that's the same thing as multiplying it by 1/2. So I get b over 2a. That's what I get when I divide b over a by 2. Then I must square it. So I get b squared over 4a squared. So that's what I'm going to add, b squared over 4a squared. I also have to subtract that same thing out here. So we're actually going to add that inside part we added times a. So when I multiply by a, that cancels the 4a squared. So we're really subtracting b squared over 4a. This part outside here is not going to be important to what we need to do. It's too complex. We're going to just look at the inside part here, the x-coordinate of the vertex. So now if I take that perfect square trinomial, I'm going to say again, we don't care about this part. But if we take that perfect square trinomial, it's going to factor into x plus b over 2a squared. This is really the important piece. That is going to be a shift left. Remember, it does the opposite. The vertex is going to shift left. So we now know that the x-coordinate of the vertex is going to be negative b over 2a. And that's what we need to remember. That's how we're going to convert into vertex form. We know that negative b over 2a, we don't have to do all of this nonsense. We can just say, I know what a is, I know what b is, let's do negative b over 2a, and that will give us our x-coordinate of our vertex. So this is the important piece of what you need to know, and we'll do some practice with this in class. So you want to write down this part, and of course when we have to find the vertex, we'll get the x value, and then we're going to get the y-coordinate by plugging the x value back into the equation. This is the same thing, it's just I'm using function notation. Since we're learning that, we should practice it. This means f of that just means take your answer. Notice this part in here is the same as this part over here. So we're just saying take the answer you got for x and plug it into the function. This is typically how we will convert from standard form to vertex form.